Hello everyone, this side Sachin from Shiksha Anusthan. In this video, we will be learning about matrix. What is a matrix? A matrix is a rectangular arrangement of numbers arranged in rows and columns. Its plural is matrices, and each number or entity is matrix is called an element. And in a matrix, the horizontal lines are called rows. These horizontal lines are called rows, and the vertical lines are called columns. Then order of matrix. The order of matrix is equal to number of rows into number of columns. So here we in this example, if you see the number of in this example the number of rows is 2, the number of columns is 3, the order is 2 into 3, or we read it as 2 by 3. Matrices are in general are denoted by capital letters. For example, like capital A is a matrix of m rows and n columns, and is written as capital A m subscript m by n. Similarly, if a matrix is B and it has 3 rows and 5 columns, it is written in such a way. Then elements of matrix. Each number or entity in a matrix is called an element. The total number of elements in a matrix is equal to the product of its number of rows. The product of its number of rows and number of columns. That is, matrix has 4 rows and 6 columns. And the total number of elements in it is number of rows and number of columns, that is equal to 24. Or m into n, the product of m into n, if m is the number of rows and n is the number of columns. Now, let us consider a matrix where 2, 4, minus 3, 0, 1, 2. Since a matrix A has 2 rows and 3 columns, so number of elements in this 2 into 3, 6. It must be noted that if a matrix has 6 elements, then it may have 1 row and 6 columns, as 1 into 6 is 6. 2 rows or 3 columns, 2 into 3 is 6. 3 rows or 2 columns, 6 rows and 1 column, such and such. Similarly, if a matrix has 8 elements, so the order, it can be 1 row and 8 columns, 2 rows or 4 columns, 4 rows or 2 columns, either ways. So if a matrix, can consider the position of the matrix. This is first position. If you consider Aij as an element in matrix where I is the number of rows and j is the number of columns, so this will be A12, A22, this will be A11. The first one would be A11, then A12, A21, A22. This is a square matrix of 2 into 2 order matrix, 2 by 2. Now, types of matrices. The types of matrices are, first is row matrix. A matrix has only one row is called row matrix, like in this case. Then a matrix in which has one column, only single column, is known as column matrix. And a matrix which has 2 rows and 2 columns, that is, the order is in like square form. This is called square matrix, where 2 rows, 2 columns, or 3 rows, 3 columns, such a way. Now, rectangular matrix, if the order is in this form, like 2 into 3 or 3 into 2, where the rows and columns are not equal, then it is called a rectangular matrix. Where if each element of the matrix is 0, like in this case, it is called zero matrix or null matrix. And then if each element of the matrix is arranged in a diagonal form, then it is called a diagonal matrix, like in this case. And this matrix has all of the elements as 0 except those leading on the principal diagonal. Except this principal diagonal, all other elements needs to be 0 to form a diagonal matrix. And in a unit identity matrix, where it is also diagonal matrix, where it has only one as element. It has only the number 1 as element in the diagonal, and others are 0. It is unit matrix or identity matrix. It is called identity matrix. The reason is because if you add or subtract or multiply any number with it becomes the same. Now let us take some examples and let us clear out with some processes of addition and subtraction. For example, find the values of x, y, a and b if x minus y, x minus 2, y, a by 2, b plus 1 are this. This is simple and it is linear. X minus 2 equal to 3, y equal to x minus 2 equal to 0, y equal to 3, a by 2 equal to 1, b plus 1 equal to 5. So in such case, x minus 2 equal to 0, so x becomes 2, y is 3 directly given, a by 2 equal to 1, so a equal to 2, b plus 1 equal to 5, so b equal to 4, so we get the values. If two matrices are equal, then the corresponding elements are also equal. Now coming to the addition of matrices. In case of addition, if suppose this two in this example, if A is 2, 5, 2, 1, 5, 6 and B is 3, 2, 1, 4, on addition we will be adding the corresponding elements 2 plus 3, 1 plus 2, 5 plus 4, 1, 6 plus 4. So the corresponding elements of the matrix will be added and the value will be decided as per the answer. To add two matrices of the same order, add the corresponding elements, and same goes with subtraction. We need to subtract the corresponding elements to get the value. So the addition of matrix is commutative, that is a plus b is equal to b plus a. It is also associative, that is a plus b whole b plus c plus a plus b whole plus c. And if you add x to a number of a constant number, if you add a new matrix or x matrix to a matrix A, if the value is b, so x minus b would also be equal to a. So it follows all the addition properties. Okay. Now transpose of matrix. What is transpose of matrix? If A is given 2, 1, 3, 4 minus 2, 4 minus 3, 2. If this is the order of A matrix, then A transpose, what will happen in A transpose, the rows will become the columns and the columns will become the rows. So that is, it becomes 2, 1, 3, 4 minus 3, 2. The rows became the columns and the columns became the rows. And a matrix and its transpose can never be added. That is, A plus transpose of A can never, addition is not possible. So two matrices are compatible for addition or subtraction only when they have same order. That is, if A matrix that order is 2 into 2 and B matrix order is 2 into 3, 2 by 3. So these two matrices can never be added. Only they need to have same orders to get added or subtracted. Then coming to additive identity. What is additive identity? If any number is added in ordinary numbers, if any number is added to 0, then the value is saved, is not changed. It remains the same. So 0 is called additive identity in normal numbers. So, but in matrices, the additive identity is the null matrix. The null matrix gives us additive identity. So if you add any matrix to a null matrix, then it will be the same. Then additive inverse. So if what is additive inverse? In normal, if you add 3 plus minus 3, 3 that will become 3 minus 3, that is equal to 0. In normal numbers, if you add a negative or a difference or the opposite sign of the number, then or the same number is added to the number, then it becomes 0. But in matrices also, if A has value, if A has value of 4 minus 3, 4 minus 2, minus 3 and 7, then the additive inverse would be we only need to modify or only need to change the signs of the numbers. And plus 4 becomes minus 4, minus 2 becomes 2, minus 3 becomes 3 and 7 becomes minus 7. Then multiplication of matrix by a scalar or real number. So to multiply a matrix means to multiply each of its elements by a scalar number. Suppose we are given a matrix 3, 2, 4, 3 and we need to multiply it by 2. So what we need to do is we need to multiply 2 in each of its elements. That will be 6, 4, 8, 6. This would be the output. As you can also see here, if 1 by 2 is multiplied in each of the numbers, the value here becomes 3 minus 2, 1 and 0. I hope the scalar multiplication is covered and you have understood the scalar multiplication. Now I'm going to the next part, that is multiplication of matrices. Compatibility for multiplication of matrices. For a matrix to be multiplied, first we need to check with the condition. For a matrix to be multiplied, suppose A is a matrix, it has order 2 by 2, and B is a matrix that has order 2 by 2. These both matrices can be multiplied. The only reason is this 2 is equal to this 2. Or you can say if A is 2 into 3, 2 by 3, and B is 3 by 2, then these two matrices can be multiplied because these two are equal. And had it been A is 2 by 3 and B is 2 by 3, then these two matrices can never be multiplied. The reason is these two matrices can never be multiplied. The reason being that these two numbers are not equal. So the condition is, if A is a matrix with m into n and B is a matrix with A by B, then n should be equal to A. N should be equal to A for matrix to be multiplied or to carry out multiplication. If the question is given to check and multiply, first you need to check if it is possible or not. If it is possible, you need to check how can you check? You can check by this process. If this n is equal to A, then it is possible. Then only carry on the multiplication process. Now let us go to the multiplication process. Suppose a matrix is given. We are given a square matrix and like 3, 4, 5, 0 to be multiplied with 1, 2, 3, 4. So how it operates, we need to choose the first row of the first matrix and the first column of the first matrix. So what we need to do? We need to multiply this 3 with 1 and this 4 with 3. So 3 into 1 plus 4 into 3. Then again we need to choose the same row matrix and to multiply with the second column. Second column of the second matrix. It becomes 3 into 2. 3 into 2 plus 4 into 4. Then we need to repeat the same with the second row and all the 5 into 1 plus 0 into 3. Here 5 into 2 plus 0 into 4. The solution comes out as we get here the answer is 3 plus 12, 6 plus 8, 6 plus 16. Here we get 5 plus 0, here we get 10 plus 0. Now on solving we get 15, 22, 5, 10. So this is the answer. As you can see, the process, the answer. Hope you are clear with the multiplication process. We can take one more example to clarify here, to make you clarify on it. Okay, like 1, 2, 3, 4 is a matrix and we need to multiply it to a matrix of 5, 6, 7 and 8. Okay. So what we need to do? First step, the first step over here is we need to choose the first row and the first column of this one. First was to check as both are 2 by 2, so it is possible. Then it is first row and first column. So what we will be doing? 1 into 5 and 2 into 7. So 1 into 5 plus 2 into 7. Now this first row itself, only only will be multiplied with this second column. That would come 1 into 6 plus 2 into 8. Now this second row will be multiplied with this first column. That comes 3 into 5 plus 4 into 7. Now this second row would be again be multiplied with the second column of the second matrix, that is 3 into 6 plus 4 into 8. So on solving we get 5 plus 14, 6 plus 16, then 15 plus 28, then 18 plus 32. That comes 19 plus, here we get 22, then 43, then 50. So I hope the multiplication process is now clear for you all. So coming to the next part, the identity matrix for multiplication. In a matrix multiplication, the unit matrix I is known as the identity matrix for the multiplication. Since on multiplying any matrix with the identity matrix in the same order, the matrix remains unaltered. You can take this example. A into I. If a matrix is A, multiply identity matrix is denoted by capital I, that is equal to A, and also if I is multiplied with A, its result is also equal to A. Suppose A is a matrix of 2, 3, 4, 6. It is multiplied by the identity matrix of 1, 0, 0, 1. And when multiplying, we get the same value 2, 3, 4, 6, that is equal to A. The multiplication carried out with the multiplication process that we just covered. So, and then another example we can take. If A is a matrix of 2, minus 1, minus 1, 3. We need to evaluate A square minus 3A plus 2I, where I is the unit matrix of order 2. So, a unit matrix of order 2 means a unit matrix of order 2 by 2. So, we know A square is equal to A into A. So, we multiply the A twice and we get the value of 5, minus 5, minus 5, 10. So, now we need to apply this in these values over here. So, in case of A square, we wrote this value. Then in case of 3 into A, we wrote 3 into scalar multiplication of A, and 2I in 2 and scalar multiplication of identity matrix. Now on solving this scalar multiplication, we get this value. It is already covered here, and the 3 into 2, then this minus 1, minus 1, minus 3, we get it as 6 minus 3, minus 3, 9, and same here 2, 0, 0, 1. And on adding all three digits, all the corresponding digits, corresponding elements we add, and we get a value of 1, minus 2, minus 2, 3. I hope I had covered all the required. Okay, so over here, if as I already covered this part, let us again understand this. If a matrix A has m by n as order, it multiplied with the matrix B having n and n by p as order, and if these both are equal, only then it will be possible to multiply. Then and if the multiplication product is C of these two matrices, then the order of C would be n into p, or m by p. So if AB matrix having order m by n is multiplied to B matrix having n by p, then the product of, and if both of this, the column of A and the row of B, the number of if A has equal number of columns as that to equal that to the number of rows of B, then only the product will be possible, and the product and the result would have the number of rows of M and a number of columns of B. Number of rows of A and number of columns of B. I hope it was clear. Now, suppose the question is given, find a matrix M such that M multiplied by this matrix gives the result of this matrix. How we need to calculate this? So we need to find a matrix M. Let us consider the matrix as the order A by B. So we know that the product should be equal. We know the multiplication process, like M having A by B and this matrix having 2 into 2, 2 by 2, and this matrix has 1 by 2. This B needs to be equal to 2 to get a value of or to get the value or to carry out the multiplication process, and this one comes from the first matrix, so A becomes 1. So now from here we get A is 1 and B is equal to 2. So now we know that the order of M is M, that is A by B, is 1 by 2. So now what we can do, we can as we know the order, we can form we can place some variables in the same order. So we place x, y in the same order as 1 by 2, and when we on multiplying we get two equations, and on solving we get the values of x and y, and so the values of matrix M. I hope this was clear. I tried to cover all the parts of matrices. Do like and subscribe our channel for more upcoming videos. Thank you for watching.